Hello student, today we will see chapter 3, pair of linear equations in two variables. Now equation you know that already. We studied the equation in one variable. Now here in previous classes you studied one variable. Now we will study here two variable. Now see here in introduction, now one variable, an equation of the form of here ax plus b equal to 0, where a not equal to 0. If it is equal to 0, then means first term is absent, it's become only b, so a not equal to 0. And this form of equation ax plus b equal to 0 is a linear equation. Here ax means here x is variable and this a is coefficient of that x, and b is a constant, and a and b is a real number also, but here coefficient of that x and b is a constant. X is a variable. If you see this, only x is one variable. Now for example, see 4x plus 8 equal to 12. Here only one variable is there. So this is the equation in one variable. Now we are studying two variables. For your introduction and understanding, I am explaining this one. 4x plus 8 equal to 0. X is only one variable, so it is a one variable. If you are solving this 4x, now here this plus 8 here coming this side, so it's become minus 8, and 4x equal 12 minus 8 4, 4x equal to 4, x equal to 4 upon 4 means 1. Simple. X equal to 1, it's a solution. One variable is there. This is the solution of one variable equation. Now see, we have to study second point is there in equation. If equation in the form of ax plus by plus c equal to 0. Now here a, this b and c are the real numbers, and here variables are x and y. This x and y coefficient of a and b respectively. A is the coefficient of that x, b is the coefficient of y, and c is a constant. So there will come numbers. See here given that already a, b, c are real numbers and a and b are not both 0. It's called linear equation in two variables x and y. Here two variables x and y, so it's become a two variables. Now see, for example, 4x plus 3y minus 9 equal to 0. This is the linear equation in two variables x and y. Now here we have to find out the solution of this equation, means we have to find out x and y. So for that one more, for solving this is the example. For solving the solutions, or we want solution, then we have to find out x and one more solution equation is required, then we can solve. But now first method is there, graphical method. With the graphical method we can find out the linear pair of equation. Here pair of linear equation means pair is given, means one or two equations are given. Pair of linear equation which has no solution is called inconsistent pair of linear equation. Inconsistent means when we are solving the equation we are getting the solution, but here some linear equations are there, you are not getting solution. No solution means it is an inconsistent pair of linear equation. Then second point is a pair of linear equation in two variables which has a solution is called a consistent pair of a solution. Means only one solution, x equal to something and y equal to something, that is the only one solution, that pair is called consistent pair of equation. Now third point is there, pair of linear equation which are equivalent has infinitely many distinct common solutions. If the pair of linear equation which are equivalent has infinitely many distinct common solutions, such a means many solutions you are getting, infinitely many solutions are coming, so that pair is called dependent pair of linear equations in two variables. This dependent pair of linear equation is always consistent. This dependent pair is called always consistent. We studied here consistent. Consistent means has a one solution. has a solution that is called consistent, then this here is the dependent. When many solutions are getting, many distinct common solution is getting, that is called dependent, and this dependent pair is equation is always consistent, means having a. Now if you see, summarize this behavior lines are there representing the pair of linear equations in two variables and existence solution as follows. Now see, here the lines may be intersect in a single point. Now we have to use the graph, and with the help of the graph we are solving, then we are getting the equations or solutions we are getting. Then the lines may intersect in a single point. In this case, a pair of equation has a unique solution. Unique solution means one solution, a solution means it is a consistent pair of equation. Already we studied here consistent. Second point, consistent pair has a solution. Unique solution means here consistent solution when they intersect, line intersect each other. When we can see, if we are using the graph, while just mathematically by expressions we are solving, they will not understand. When we are drawing the graph, or with the help of the graph we are solving this linear equation, we are getting the solution. Then lines intersect, then we are getting unique solution. That pairs that equation is consistent pair. If lines may be parallel, if lines here also all this parallel, when on graph only you will understand line is parallel or intersecting, whatever. So lines may be parallel. In this case equation have no solution. When lines are parallel, there is a no solution. You will understand in exercise 3.1, there is a first exercise, with the on graph it is there. Then we will solve that. We will see parallel means there is a points you will not get, means equation means solution you will not get. Inconsistent pair of equation. Now see here, third point, the lines may be coincident. In this case, the equation have infinitely many solutions, means it's dependent consistent pair of equation. Already in introduction, in second point, we studied that here consistent means what and dependent means what. Here, if it is a coincidence means while on graph, when you are drawing your linear equation with the help of that point x-axis and y-axis, then that line will coincident means what, many. So there is a many lines are there, but they are coincident, so you are getting the infinitely many solutions. Here down we will study in the third point. This third point we will study. Now see here, third point, the lines may be coincident. In this case, the equation have infinitely many solutions. Dependent or consistent pair of equation. In introduction of this graphical method, we studied that, see here, consistent and dependent. Also we study dependent and consistent lines. Means when these lines are coincident. Coincidence when, remember we are studying the graphical method. When we are drawing your two variables equations are there, then you will get the line coincident. Then coincidence means here many lines will coincide to each other, so you will get the infinitely means there is a no limit, many solutions you will get that. Here now in this table also we will study. In third point again we will study, but again see here pair of lines for example is given. Here x minus 2y equal to 0, and another equation is there, 3x plus 4y minus 20 equal to 0. Here in both equation two variables are there. Then this x means a1 and 3x means here a2, this, and b1 and b2. If a1 upon a2, here b1 upon b2 and c1 upon c. So if you are writing here, see here a1 is 1 and here a2 is 3, 1 upon 3, like that. B1 minus 2 and plus 4, here is minus 2 upon 4. Here in this first there is a constant is not there, c is not there, it is absent, means c1 is 0, and here minus 20, c2 is minus 20, that you are written. See here we have to compare this line, this a1 upon a2 not equal to b1 upon b2. Now you will see here 1 upon 3 and minus 2. If you reduce form also, you will get the minus 1 upon 2. Here 2 is there, 4 is there, means minus 1 upon 2, or like that only. It is not equal to. This ratio is not equal to. Not equal to means what? This is intersecting lines are there. This ratio a1 upon a2 not equal to b1 upon 2, then it is a intersecting lines. This we saw here, not equal. a1 upon a2 and b1 upon b2, that is minus 2 upon 4 is not equal, means it is a in graphical representation. When we are drawing, if these two lines we are drawing, then it is a graphical representation. It will say intersecting lines, that these two lines intersecting to each other in a one point, and that one is the solution of these two lines. Here we are getting exactly one solution, that is the unique. Exactly one getting solution means what? It is become a consistent, that already we see. Now here also two equations are given. If you are finding a1 upon a2 and 3, well, see here, if you reduce form, you have to see here reduced form is what? 1 upon 2. Here if you will see here, if you reduce form is 1 upon 2, here again 1 upon 2, and minus become plus, so this is also 1 upon 2. 9 ones are 9, 9 twos are 18, means all are same. See here then, a1 upon a2 equal to b1 upon b2 equal to c upon c2. Now see here, these all ratios are same, so it is a coincident lines, means you are getting infinitely many solutions. Now here third equation, x plus 2y minus 4 equal to 0, then 2x plus 4y minus 12 equal to 0. Then here again we have to find out. Here now see 1 upon 2, and here 2 upon 4 means this is 1 upon 2, means a1 upon a2 equal to b1 upon 2. But this 4 ones are 4 and 4 threes are, means 1 upon 3. This is not equal. This c1 upon c2 is not equal to this 2. 1 upon, you are getting minus plus. So 4 upon 12 means 1 upon 3, means this is the parallel line. If parallel lines are there, there is a no solution, means it is a inconsistent here. Now see here coincident line. These all ratios are same, so it is a coincident line, and you are getting the infinitely many solutions here. Now see, I told here third point is there. Here infinitely coincident are there. When coincident, because all ratios are equal. Why many it's getting? Because ratios, many ratios will come same. Those are in proportion. Now see, this is the 2 upon 4, all different. 2 upon 4, 3 upon 6, minus 8 upon, but their ratios are coming. Those numbers are different, but ratio is same. So many numbers will come like this only, though number is different, but maybe ratio. So it is infinitely, because, and they are coincident because their ratios are same. If ratios are same, they are coincident, and other many numbers are coming. 1 upon 2, here means if 5 upon 10, then also you will get 1 upon 2, 6 upon 12, then you also get like this. So infinitely many solutions. Meaning of this is that ratios are coming same. So infinitely many solutions you are getting. Now third point, x plus 2y minus 4 equal to 0. 2x plus 4y minus 12 equal to 0, and then see the ratios a1 upon a2, b1 upon b2, 1 upon, they are coming same. How here 2 upon 4 it means 1 upon 2, 2 ones are 2, 2 twos are 4, 1 upon 2. These two are same, means here written 1 upon a1 upon a2 equal to b1 upon b2. These two are equal, but here see minus plus, but 4 upon 12 means 1 upon 3. This is not equal. Only to a1 upon a2 equal to b1 upon b2 is equal, and another c1 upon c2 is not equal to this. So it is a parallel lines, and parallel lines is there is a no solution. So here is becoming inconsistent. Here now see how in graph you will get like this. When you are drawing the graph and two equations, linear equations are given, their points you are drawing on x-axis and y-axis, then you will get the intersecting lines like this you are line getting, and where it is intersecting, that point you are getting, that means it is a solution of that equation. So intersecting line, here parallel lines, here no intersection. Parallel means you know that there is no intersection, intersection is not there, so you will not get the point and you will not get the solution. So parallel lines don't have solution. Here now coincident line, here many coincident line is coming, we saw that ratios are coming same, so many coincident lines is coming, so you are getting the many solutions. And this coincident line is coming like that, on here two lines are there and coinciding the another line, so you are getting the many solutions. In then this all introduction we are using in exercise 3.1. Next video we will see exercise 3.1, so don't miss out this video.